Good afternoon. Aloha. Bonjour. Welcome to 3.3. Excuse me, 3.1. I'm tripping. So at the end of the day, you talked a lot about a derivative, how to find the formula. Now we're coming on to the basics of what we call the power rule. And we love the power rule because we don't have to write out the limit formula and the quotient difference or the difference quotient. We can just simply look at the formula and say that when you have something to the power x to the power, you literally bring the power down, multiply that by x to that power minus 1. All right, very simple, basic rule. If you can do this, then you're good to go. All right, so basically we say, well, what is the derivative of, we can rewrite this instead at the bottom of x to the negative third power. So what do? The power is negative 3. We bring the power down. We take negative 3 minus 1. So we got negative 3x to the negative fourth power. Or we could say this is negative 3 and this is a power because the exponents go to the bottom. We can do it like that. Okay, cool. And that's like a simplified version, real straightforward. All right, here's another one you're going to see a lot. You can probably just memorize the answer. All right, as we take the derivative here of x to the 1/2 power, which is literally the square root of x, we're going to bring this power down. We're going to take x, that power, minus 1. All right, so we got to be careful with that. This is x. 1/2 minus 1 is negative 1/2. Okay, cool. So we got 1/2, and then you got x to the 1/2 power down here at the bottom, which is literally going to be 1 over 2 root x at the bottom. So whenever you take the derivative of x to the 1/2 power or the root x, all right, this is going to be the answer right here. Cool. All right, so maybe you should pause the video and step up and take a challenge. Pause it and see if you can get an answer here. No problem. So we're going to take the derivative. We can rewrite this as x to the negative 1 because inside of the root is 1, x to the first power over the actual root, which is 3. Okay, so it also looks like that. Okay, cool. So let's bring this power down, and now we got x negative 1/3 minus 1. All right, nothing to get scared about. We love fractions. It's all good, right? 1 is just literally 3 over 3. So we got negative 1/3 over x to the negative 4 over 3. Capiche? All right, so let's write this out again. We know this is going to be here at the bottom. Okay, so we got our negative here. We got our 3. We got x in here. So we know that this is going to be root 3, and then a 4 is on the inside. So we can simplify that. That can be simplified, right? So we could do that or we could leave it. X is going to come out, and this is going to be root x like that because any threes, any triples are going to come out, and this is still the third root right there. Not x to the third, it's the third root. All right, all right. So here, let's talk about this now. This is basically saying if I have a c times a function, the derivative means you can separate the 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 constant x, no x's, I mean 1, 2, 3, 4, a million, right? Absolute value of 5, ln of 2, any constant basically, and multiply that by the derivative. Okay, cool, pretty straightforward. And we could rewrite them here. It's saying we can add the derivatives, we could subtract the derivatives, we can do whatever we deem necessary. So here, what we have is 5, and I can pull that to the side and say, now take the derivative of x squared plus 3 derivative of x plus the derivative of 2. See how I can just separate that. All right, so now what do I have? I have 5 times 2x. The derivative of x squared is just 2x. I have 3 times the derivative of x is just literally 1. That 1 power comes down. 1 minus 1 is 0. X to the 0 power is just 1. And the derivative of any constant, you know, is just going to be 0. Right? So my derivative is just going to be 10x plus 3. That's my derivative. Cool. All right. Now let's take our time. All right. So the same thing here. I got the square root of 3 times the derivative of x to the 7th power. Maybe make that look a little bit better. All right. We got x to the 7th power minus, this is over 5, which is just 1/5, the derivative of x to the 5th power. All right. Plus the derivative of pi. All right, well, what is this? So this is going to be root 3 times 7 x to the 6th power. Cool. 1/5 is going to be times 5 x to the 4th power. Okay, plus the derivative of pi, because pi is a constant, 3.14 something something something, is just 0 right here. Okay, cool. So let's finish this up. So we got our 7 root 3 x to the 6th power. It looks like these 5's are going to cross cancel. All right, so we got minus x to the 4th power. All right, and that is really our answer for what we want. Okay. Now, can it get a little spunky? Yes, right? Because you got these roots and you got these fractions. We're not scared of fractions. We're not scared of roots. We just take our time. So if you take your time, then it's not that bad. All right. So what does that mean? So I'm going to have 5 times the derivative of, I'm going to rewrite it as x to the 1/2 power. Okay. All right. Minus, I got 10 right here because that is my function that's my constant on top, and then I have x to the negative 2 power because it was at the bottom, x squared at the bottom in the denominator. All right, then I'm going to recognize this 1/2, so that's going to be 1/2 times the derivative of x to the negative 1/2 power, because that was also on the bottom. All right, cool. Are we scared? No. A little bit nervous? Yeah, probably. You probably are a little bit, but it's nothing that you can't handle. All right, so we got 5 times, we already know what that looks like, 1/2 times root x. All right, cool. So that's not a problem because we've done that already. Okay, minus 10 times that -2 comes down, x, -2 minus 1 is -3. Okay, cool, not too bad. This one is the one you kind of got to be careful with. Okay, so we're going to bring that -1/2 down, and this is just going to be x, right? So remember, this is x, -1/2 minus 1, which is x to the -3/2 power. Okay, so we're just going to put that there. All right, so this is -3/2, right there. All right, so let's start simplifying things here. So we got this here, okay? We got a negative 10 and a negative 2, which is going to be 20, and that x to the negative third power goes to the bottom, and that's going to be x to the third power. Hopefully that you can see that nicely. So x to the third power. All right, this is the one we got to deal with over here. So that negative and the negative is going to be, excuse me, negative and a positive multiplied. This is going to be negative 1/4 right here, and we got that, okay? So that is going to be at the bottom, right, of something, and it's going to be the square, and then inside the root is going to be that, okay? Cool. So with that being said, we can take out any double. So there's like an x squared and an x in there, so this has got to come out. All right, so this is going to literally be x like that. Okay, so we're gonna go here with it, right, because that 1/4 is already at the bottom, and that's gonna be our answer. So it's nothing really hard. You just gotta stay with the problem. All right, cool. All right, this one is a little tricky. Don't get scared. We can literally know what to do. So we're going to bring that power down and multiply it. So it's going to be that. It's going to be x squared because that's going to go down one. Maybe we take our time a little bit on this one here. We'll take our time on this. All right. So it's going to be that. So I'm going to bring my power down, and I'm going to have x root 2 minus 1. All right. Okay. So nothing too hard. This is going to multiply to 2 root 2 x root 2 minus 1, since you cannot simplify that anymore. All right. Cool. Let's go with our second derivative. All right. Second derivative. Now, all a second derivative is the derivative of the first derivative. If you want to take the third derivative, you take the derivative of the second. All right, cool. Pretty straightforward. So f of x is x squared. Okay, what does that tell us? That the derivative of f of x, or f prime of x, is literally going to be 2x. Take the derivative of that. My second derivative is going to be the derivative of 2x, which is just 2. Okay, was it that easy? Yes, it is that easy. All right, so we're going to go now here with g of x, which is x to the third power. All right, so g prime of x, the first derivative, bring the power down. 3 minus 1 is 2. All right, let's take the derivative of that. My second derivative, bring the power down. 2 times 3 is 6. 2 minus 1 is 1, so it's 6x. All right, cool. All right, now this is the harder one. Same thing. Maybe you want to pause the video and do this on your own, because it only works when you do it. Math is not a spectator sport, it's a participation, right? You got to be in part of it. All right, so we know that k prime of x is literally going to be 1 over 2, because we did that already, correct? We did that earlier. All right, so the second derivative is actually going to be obviously a little bit harder, right? So, or we could have said this is 1/2 times this here, right? So what does that mean? I bring this power down. That's going to be negative 1/4 right here. And then I'm going to do here x to the power of negative 1/2 minus 1. All right, so that's telling me that this is going to be negative 1/4 x to the negative 3 over 2 power. Okay, so now I have negative 1 over 4, and I bring this down. This is going to be the square root of x to the third. All right. So I could leave it like that, or I could take some things out of the bottom because one of those squares comes out and you have that right there. All right. So when do we use this? All right. So you have this position. It's given by this function. S is usually speed. So we can have speed, but if we want to find the first derivative, which is what we call velocity, and you know from physics, velocity is just the speed with a direction, all right? And actually, S is kind of like more of your position, where you at a certain time. So at time 0, this is how far you've gotten. I've gotten 100 meters. I've gotten 12 meters, right? Because remember, S is the miles per hour, right? So you've gone 5 miles in 1 hour. Hopefully not. That's Bay Area traffic, right? So let's go here and let us go and find acceleration, which is literally the first derivative of position. Excuse me. Back up. Velocity. All right. So we just take the first derivative. All right. We bring that 2 down. This is literally going to be this. 2 minus 1 is 1 plus 5. Okay, so that's how fast you are. How's your speed at direction? And most of you from physics recognize that negative point, excuse me, 9.8, which is the force of gravity on any objects, is obviously negative because velocity is telling you gravity is pulling you down. All right, now let's find what we call acceleration. Okay, acceleration is literally the second derivative, right? How fast are you speeding up? I love fast cars. I don't look at the velocity. Everybody that if you got a faster car, the Jaguars, right? I'm not talking about the BMWs, but the M5s and the Porsches. We want to know how fast are you going from 0 to 60 in 3 seconds. And I don't care about the top speed. How fast do you go from 0 to 60? That's your acceleration, right? How fast are you speeding up? Take the second derivative, which is literally just going to be this 9.8, which is the speed of gravity for something that is thrown in the air, because this is just a parabola that looks something like that. So when you throw it in the air, how fast is it speeding up towards the ground? It's the speed of gravity. All right. Thank you. Aloha and have a good day.